Hey guys, I'll be explaining question F and G of last Codeforces Tip 3 round. So let's start with question F. I'll tell you what this question is about and then we can move on to its solution. So here we are given a problem set in this form, and these are A1, A2, A3 are the complexities of this problem, and these are given in sorted order. And imbalance of this problem set is defined as the maximum difference between consecutive problems. So for example, if difference between these two values d1, d2, d3 and d4, the maximum among these four values d1, d2, d3 is going to be your imbalance. So we are given a problem set and we know how imbalance of a problem set is defined. So our task is to create a new problem, create at most one problem, and we have to make sure that the imbalance of a problem set after creating this problem is as less as possible. And instructions for creating this problem are as follows. So along with this problem set, you are also given array f, d and f of size m and k, I think. Yes. So to create a new problem, you have to select one element from array x and one element from array d, add both of these values fi and dj, and this is going to be complexity of your new problem. And then you add this new problem to your problem set, initial problem set which was given to you. It can, whatever it depends on its value where you add it, you can add it here, 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 depends on its value. And again after that you'll calculate the imbalance of this modified problem set, and you want to make sure that this imbalance is lesser than before. Otherwise, I mean, what's the point? You can choose not to create a new problem. So how to approach this? So I mean, you have to there are a few cases here that we must first. Okay, let me take on this example to make it even more clearer. So this is uh, your A array complexities, initial complexities of your problems, and imbalance of this array is 5, 5, 5 and 6. So the maximum difference is 6, so your imbalance is 6. And array f and g are as follows. This is your f and d, sorry, d and f, sorry. It doesn't really matter. 11, 14, 16, 13 and 8, and 16, 4, 5, 3 and 1. So if you had chosen 13, 16 from here and 8 from here, so complexity of your new problem would have been 24, and 24 would come somewhere in between 20 and 26, and your new values of differences is going to be 6 is going to be removed and 4 and 2 are going to be added, and your new imbalance is going to be 5, because 5 is of course less than 6 and maximum among the difference values. Oh, why did, and it's better than your previous the previous imbalance that you were getting, which was 6. Now you have a better imbalance, which is 5. And this is the solution of this problem. But how do we choose these elements? How do we go on about choosing these elements, optimal elements? So few cases here. Let's say your a1, a2, a3, a5 dot 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 an. So these differences all are equal. Let's say that. So whenever, let's say you do make a new problem and add it somewhere between any two values or at the start or at the end, thing is it will change. If you put it between some values, it is going to change the difference that was coming before from these two values because a new value has been added here, but other values are going to remain unchanged and they are only going to act as your imbalance value for your current problem set. So point I'm trying to make is nothing would change if all these all of these different values are equal. Even if you can modify one of these difference values by adding a new problem, the rest are going to be as they were before, and because of that, your imbalance value is not going to change. So in this case, you can simply print. You can simply choose not to create any problem because you have a choice. As I told you before, you have to create at most one problem. So you choose here, just don't create any new problem and move on. Print the initial value of imbalance. Now the second, but just remember this, keep in mind that if you have just two elements given with you, so you don't include this case with the case that I just discussed. This is going to be handled separately when n is equal to 2. So yes, other case is going to be, let's say, your difference values. I'm skipping, I'm just coming directly to difference values. dn minus 1. You sort them. Let's say these difference values are sorted. Your dn minus 1 is going to be the maximum among them. And if dn minus 2 is also equal to is same as dn minus 1. So if this maximum imbalance value difference value repeats, if dn minus 2 is same as dn minus 1, again doing anything would not make a difference because you create a new problem and with that you modify this dn minus 1. You can split this dn minus 1 with, replace these with smaller values, but it is not going to make a difference, but because dn minus 2, which was same as dn minus 1, remains in the problem set. So again, your imbalance value is not going to change and you can print the initial imbalance value and move on. So now the third case is that, let's say you got your difference values in sorted order and dn minus 1 is max, but it is unique. So there is no other difference value which is okay. So when I meant they are in sorted order, they're not strictly increasing, they're just increasing. Yes, so this max value is unique. So here if you are able to modify this difference value, add a new problem wherever this difference value was occurring and split it into smaller values. And when I'm saying that you modify it, you split it, what I mean is that, let's say you got this complexity ai and ai plus 1, this d, let's say difference value here is the max that you are ever going to find and it is unique. If you create a new problem and you add it which is greater than ai and less than ai plus 1, so it is going to lie somewhere here. So your new difference values are going to be these are going to be your new difference values, right? And sum of these two difference values is going to be equal to di, which was difference between these two elements before you added anything. So this is what I mean. So what should be the value of a new so that your imbalance is minimum? Where would you like it to be? So if this is ai and this is ai plus 1, let's put some numbers here, 15 and 25. If your a new, your d was is 10, if your a new is 17, so new values are going to be 2 and 8, and your new imbalance value is going to be maximum of 8 and the difference values that you are getting from the elements which are behind and ahead of it. this is going to be your new imbalance value. Maybe it's not clear. Let me try to make it more clear for you guys. If it's clear, you can of course move ahead. For those who are still wondering what is happening, let me try a little harder. Yes, so these are your difference values. Let's say D3 is your max, and it's unique among all the difference values. And this A3 is 10, A5 is 25, and if you add a new, which is let's say 17 somewhere here, so your new difference values is going to be 2 and 8, and you can forget about 10. So now what is going to be imbalance value of this problem set? The imbalance value of this problem set is going to be maximum among D1, D2, D4, D5 and D6 and 8. So whichever is the greatest is going to be your new imbalance value. So what if all these difference values, D1, D2, D4, D5 and D6, what if let's say all of these values are less than 4? Let's assume that they're less than 4. So obviously your new imbalance value is going to be 8. But, so okay, fine, your imbalance value is 8. But can we do any better? So what if your new complexity of your problem set was, let's say, okay, it's 20, it's not 25. So sorry for that. Let's say if it's, okay, it's 15 and not 10. Okay, let me write it again. Nothing to worry. This is 15 and this is your 25. Let's say if your a new was 21 instead of 17, what then? Your 15, 25 and your 21 will lie somewhere here, and your new difference values are going to be 6 and 4. And what is your new imbalance value? It's max 6 comma 4, because we assumed everything is less than 4. It's going to be 6. But can we do any better? What if a new was 20? So 15, 20, 25, 5, new difference values 5 and 5. The new imbalance value is going to be max 5 comma 4 and 5. Now can we do any better? And the answer is no, we cannot. So if you guys got the idea, what I did was I tried to find a number which was closest to the middle element. So I want a number which is closest. This middle element is going to be AI plus AI 1 by 2, and I want my a new to be as close as possible, because here I assumed in the example that I gave you, I assumed that I can create whichever value I want. That is not the case. We cannot create whichever value we want. We have constraints. So we want our a new values to be as close as possible to this term. I hope this is clear. And then we can compare them with the rest. If our imbalance is, if we can get a better imbalance, good for us. Otherwise we cannot. So how do we get a problem whose complexity is as close as possible to AI plus 1 by 2? We have, let's fix this term. Okay, we can find our dmax, and then we can find, after finding our dmax, we can find which are the two elements between which this dmax occurs. So we can get, once we get dmax, we can get AI and AI plus 1, and after that we can get this value as well. Let's call it middle element. Okay, ME. Now we have our D and F elements with us, and we have to calculate, we have to select one element from D and one element from F such that their sum is as close as possible to our ME. For that, we are going to be using a binary search, and we'll iterate over D and then use binary search to find suitable values in array F. So how we will do that? Let me show you. Make sure to sort your F array F. So let's say we are on D4. These are on sorted order. We are on D4, so let's assume that we have chosen this value D4, and we want to choose some value of F such that we are as close as possible to ME. If we are equal to ME, well then nothing can be better for us, but close is also good. So we want our F to be as close as possible to ME minus D4. If we can find such an F which is equal to ME minus D4, well, we have found a problem whose complexity is ME. So we'll look for F in this sorted F array. If we find element which is exactly equal to F, well, good for us. But if we don't find it, let's say our value of F lies between F4 and F3. So what we are going to do is we are going to assume our F. So we're going to make two cases here where we choose F3 and one case where we choose F4 and calculate the new imbalance in both of these cases and select whichever is the minimum of them, whichever is the better of them. This is how we are going to proceed. So we go for every value of D, we're going to calculate a desired value of F and then look for values which are closest to our desired value of F. And this can be done using upper bound, finding our upper bound and lower bound. We can easily find these values. And then for all these cases, we'll compare our result, and whichever is the minimum, we'll return it. So I mean, conceptually it was clear what I'm trying to do here. Let me show you the code quickly, because I mean, implementation isn't that difficult if you have understood what needs to be done. Yes, so first I calculate these difference values, and if they are unique, all of them are same, I just return the initial imbalance values. After which I again go on to calculate. I go on to find the problems between which you get the max difference. So whichever difference equals to the max value which I have stored in mm, I assign it to this p variable, and at the same time I'm also checking for whether these values repeat or not, because if they repeat, if my c is greater than 1, well, it's pointless to make any new problems. I'll just return print and return. But if that is not the case, then we can move on and create new problems and try to see if we can reduce our imbalance or not. So my first, this lf variable, as you can see here, is the middle value which I talked about. me, it's same as me, and we iterate over this d vector, calculate the closest calculate the desired f value, that is lf minus okay. So I've changed the nomenclature. Instead of using d and f, I've used a and b, so don't get confused here like I did for a moment here. Yes, so I've calculated the closest desired value of b which I want, and then in my array b I look for it. I go and look For the value which is greater than it, I check that case, and I check for the case where my f is where my b value is smaller than the one I require. So I check these cases here, and what if and the case one case where my lf the value my f value is either before or end of vector b. So that is that those cases I'm handling differently. So once that is done, every time I do it, I check if I can reduce my answer or I cannot. If I can reduce my answer, well then I do, and if I cannot, well my answer remains the same, and then at the end I print it. So yes, this was question F, and now let's move on to question G.